Electrical signals can pass through dendrites and axons. This is what allows neurons to carry information. When neurons need to communicate with other neurons, they release chemicals called neurotransmitters at the end of the axon. This allows them to transfer information. The animation you're seeing has been slowed down a lot. In reality, neurons can release neurotransmitters up to 1,000 times per second. The billions of neurons present in the brain connect to each other. All of these connections form a network that allows the brain to do its job. This network of neurons allows you to record memories, make movements, and to see images. Vision provides some of the most important information for humans. We rely on vision more heavily than we do on any of our other senses. The sense of sight is used to gather information, as you're doing right now while you're watching this video. Think about how hard it would be to get to school in the morning if no one could see. Vision is what people use most to spot traffic signals and to help determine when and where to safely go when they're walking or when they're driving. It's also chiefly through vision that we recognize other people.
First of all, when you have light, you can have very bright light or very dark, very somber light. And the eye protects itself by having this, the iris, which sort of is like a camera, which increases in diameter or decreases. So if there's a lot of light, you sort of decrease the diameter of the aperture. And if there's less light, well, you sort of, increase the diameter to get more light into the eyes.
The part of the eye that receives images are the nerve cells located on the retina. The retina is located at the back of the eye. It's like a screen in a movie theater. Images from outside of the eye are projected onto its surface.
There are cells in there which change electrical properties as a function of the light. So if a light strikes some of the receptors, which we call, for example, the cones and the rods, which a lot of people know about, if the light strikes these receptors, there's an electrical activity that is generated.
The optic nerve is a kind of a wire carrying visual information from the eyes to the back of the brain.
We have information coming in from nerve cells in the eyes, and these are the axons of those nerve cells that are going to come together and become the optic nerve. They're going to project all the way to the back of the brain to the visual cortex. This is the part of the brain that allows us to see colors, shapes, and objects.
Finally, after traveling through the eye and the optic nerve, visual information is brought to the back of the brain to be analyzed in a part of the brain called the visual cortex. In the visual cortex, neurons work to understand all the information that is coming in through the eyes, including the colors, the shapes, and the movement of the things around you.
But you actually have many video screens. So if you imagine that you're seeing an image at any moment in time, it's repeated maybe 20 times in your visual cortex, that you have this image repeated everywhere. But each one of those screens is seeing it in a different way. So some of them only see the shapes that are there, and some only see the colors, and some only see the motion. So one of the first things, and one of the most interesting things that the brain does, is to chop up the visual image into features that it cares about: shape, depth, texture, color, velocity, things like this. And they're specialized in different parts of the brain.
This is how some parts of the brain analyze information coming from every part of your body. While some parts of the brain analyze information, other parts are responsible for completely different tasks, like planning and controlling movements.
What the brain really does is it animates you. It makes you have behavior. So it does this by way of its connections both to those nerves that go to the muscles, as well as its connections to nerves that are in the brain.
There are several types of motor acts. One of the most basic ones that every animals have are called reflex. For example, if you put your hand on a hot stove, there's a reflex we'll call a withdrawal reflex. You're going to take your hand out of the hot stove because it's burning your hand. That's one of the first ones. These are very, very important reflex for protection. The second one is stereotype activities, motor activities. Walking is one. So when you walk, you can chew gum and talk at the same time, and you don't have to constantly think about walking. So this is a stereotype movement. And the other one is voluntary movement. For example, if you decide to reach for a glass of water, you decide yourself that you're going to do it.
Going back up here to the primary motor cortex, this is the region of the brain where we have lots of motor neurons, and they're then going to project down into the spinal cord and in turn control all of our limbs. This is where, if we have a lot of neurons that control our hands, this allows us to move our hands and do all sorts of things like catch a baseball.
Once the brain has decided which movement to make, it has to send this information to the muscles that carry out the movement. The command to move is sent by neurons through the spinal cord.
There are several components of the brain that makes us move. And one of the first important ones is the cortex. The cortex is the out layer of the brain. And the front of the cortex, this is where we make the decision, we have the decision making, basically. So if you decide, for example, to reach for a glass of water, this is where it's going to happen. Afterwards, once the command is launched, what's going to happen is the cortex is going to send the command to the muscles. In order to do this, what it does, it sends two neurons from the top of the brain. It goes down to what we call the spinal cord. And when it reaches the spinal cord, it will contact, those neurons will contact what we call motor neurons. And those motor neurons will exit the spinal cord and then will contact onto the muscles.